Alright guys, welcome to this page of the notes. What we're doing here in this section is we're using the relationships that we know about parallelograms to prove that a quadrilateral is in fact a parallelogram. So what we'll do is we'll go ahead and take a look at a couple of example problems where we do that. Here's what I want you to do. I want you to show that each quadrilateral, I've given you a diagram here, it is in fact a quadrilateral. 1, 2, 3, it has 4 sides. I want you to show that that quadrilateral is a parallelogram for the given values of each variable. So here we go. I have given you some information about the sides of a parallelogram, and you'll remember from the previous page that the criteria is one pair of opposite sides must be congruent. So if, jeez, I keep using my highlighter and I want a pen. If one pair of opposite sides are congruent, then it's a parallelogram. Okay, so all we have to do is show that one pair of opposite sides are congruent. Well, bust out a calculator. Don't fat finger something on your calculator when you plug in the values I've given you, and we'll go ahead and do this. So here's what we're going to do. I'm going to go ahead everywhere I have an X, plug in a 7. Right there is an X, so I'm going to plug in a 7. Right there is an X. So you're going to plug in a 7. If you do that, 7 plus 14, let's see, quickly, we wind up with 21. 3 times 7, oh, look at that, 21. And so right there, I'm done. I know that side BC is congruent to side AD, and that's enough. I just have to show that one pair of opposite sides are congruent, and I know that it is a parallelogram. I know that I have a parallelogram, and I did that. We can, though, go a little bit further. I mean, why not? I've got the information here. I know that y is equal to 4. So y, I'm going to plug in a 4. I have a y, so I'll plug in a 4. And what do we get? I get 5 times, right, 5 times 4 minus 4, that's going to be 16. I have 2 times 4 plus 8, which also is 16. And so even if I had done these two sides, I still wind up with the same thing. 16 is equal to 16, which means that side BA is congruent to side CD. So either way, doesn't matter whether you plug in X or plug in Y, you're going to get the same answer I get. Yes, this is a parallelogram. Yeah, it's a parallelogram. All right, let's go ahead and try another one. So what I've done is I've given you a figure and I've given you some information about that figure. In this case, please notice the information you've been given is you've been given information about the angles. Well, what do we know about the criteria but for the angles of a parallelogram? I have to show that both pairs of opposite angles are congruent for the figure to be a parallelogram. Please notice that this one is different. Up above, I only had to show that one pair of opposite sides were congruent. But for this theorem, I have to show that both pairs of opposite angles are congruent. You cannot stop at one pair of opposite angles. You must show that both pair of opposite angles. That's the way that this theorem works. So for the sides, you only have to show that one pair of sides are congruent. When it comes to the angles, you must show that both pairs of opposite angles are congruent. Okay, no big deal. Here we go. I know that z is equal to 11. So everywhere I have a z, we're going to plug in an 11. There's a z, so we'll plug in an 11. There's a z, so we'll plug in an 11. Plug and chug. Don't fat finger something on your calculator. I wind up with 118 degrees for angle F. Hang on, let me do this. Angle F equals 118. I get angle H equals, I get 118. So far we're off to a great start. Angle F is congruent to angle H. But unlike with the sides, that is not enough. Just showing that one pair of opposite angles is congruent, not enough. I must show both. I got to show that both pairs of opposite angles. So we need to keep going in this case. W. There's a W. There's a W. So angle E, I go ahead and I plug a 4.5 in for W. Don't fat finger something on your calculator. I get 62 degrees. Angle G, once again, I get 62 degrees. 14 times 4.5, then subtract 1. I get 62 degrees, and I have just shown angle E is congruent to angle G, and now I have everything I need. I've shown that both pairs of opposite angles are congruent, and so once again, yes, it's a parallelogram. Okay, so there you go. That's using the criteria that we talked about on the previous page. The criteria for the sides of a parallelogram. Criteria for the opposite angles of a parallelogram. We didn't do an example problem with it, but we could have also done one with the diagonals. If I can show that the diagonals bisect each other, then I know that the figure must be a parallelogram. All right? What we'll do on the next page of the notes is once again look at those criteria for determining whether a figure is a parallelogram. So I'll meet you on the next page.